Hey, hey!
Our next speaker is Ryan. He's going to talk about something really cool he's been working on. I remember this super early on in like May of 2018, I think. This is like super early, like very initial fundamental discussions. I want to mention something interesting first. A lot of like, he's obviously going to mention Deno, right? A lot of the very interesting ideas and implementations came from like taking code and working on it in like a non-huge a node, like the node issue tracker is a huge space, and like experimenting and making a lot of really cool changes. And actually, I remember Anna worked on worker threads in like a fork that existed for Node for a while, and that like helped it evolve in at least I'd like to think Anna can maybe say if it didn't, it made it move faster. So I just want to say I work on Node like a bunch, and I opened a bunch of PRs for Deno for like cancellation APIs because I like cancellation APIs. It's one of my things now, and it's very different to work on like on something like Deno versus something like Node. It's like it's sometimes it gets stuck, but when it moves very quickly. So if you want to get into open source, and I'm sorry, Ryan, if you get a bunch of people who are like new to code, it's a good place to check. So I'll let Ryan take it, and thanks a bunch.
Thanks for those PRs, by the way, and of course, everybody is very welcome to contribute to Deno. It's a pretty fun project. Very different than the Node code base. Sorry for my infinite regression screen here. Let me fix that. It's a fun project to work on because it's all in Rust and it's new. I'm going to just give kind of the basic overview of what we're doing here. I think apologies to people who know a bit more about Deno already, but I think it's a pretty new project, and just want to kind of give the basic intro. Deno is a new command line runtime for JavaScript and TypeScript, and it aims to be fun and productive. I think that dynamic programming languages run the world. Most of the business logic in the world is written in JavaScript or TypeScript or Python or Ruby or Lua. Dynamic programming languages are really useful because you can move very fast in them. And I think it's a good scripting platform is too useful of a tool to accept the status quo. So this project is attempting to make something fun and productive. But undertaking this project is non-trivial. So we try to make it fun and productive for the users, but we have to do quite a bit to give the appearance of everything working out quite nicely. So I'm just going to go over a few of the features here of kind of the main shape of this project and give you an idea of how this thing works. So as I said, this is a thing for executing JavaScript and TypeScript, by the way. One thing you might notice is that Deno is a single executable file. We do not distribute a tarball full of header files and ancillary directories that need to exist in a certain place. It's a single file, and it's always and forever going to be distributed as such. And we try to keep it as compact and independent of system libraries as possible. And this executable is all you ever need to run any Deno program. So, this makes it really accessible for using it for small scripting tasks, right? If you can just kind of drop it into any system, this single exe file or executable file, and you should have a very robust scripting platform available to you. There's not a lot to set up. We ship on Mac, Linux, and Windows. And as I mentioned before, TypeScript is built into this. That means that the TypeScript compiler from Microsoft is actually somewhere inside of the Deno executable. And we do a bunch of trickery to make this work out nicely. The TypeScript compiler is the type checking operation of TypeScript is a relatively slow operation, and we try to make that as fast as possible by using V8 snapshots to start up the TypeScript compiler quickly. When we don't need to do type checking, we can transpile from TypeScript to JavaScript very fast. I think this is one of the main benefits of TypeScript, actually, is that it is a superset of JavaScript, and the operation for type stripping to strip out the types is a relatively simple one, and we do that with a Rust TypeScript AST library called SWC. But of course, normal JavaScript is also supported and is a first-class citizen, of course, and does not incur any overhead when using it. So if you use just normal JavaScript, it does not go through the TypeScript compiler. It should run very fast and smoothly as you're used to with Node. And yeah, the general idea is that, as you're kind of scripting things, like you start out in a really hacky mode, like you open a file, you just start smashing the keyboard, things kind of develop organically from there. And, 9 times out of 10, you throw away that code and never look at it again. But sometimes that code kind of develops into something that sticks around for a while, kind of becomes part of a bigger project. And at that point, TypeScript has proven itself to enable larger, more complex JavaScript code bases. You kind of want to have the type checking when you're dealing with large, complex things, and then hopefully Deno allows you to kind of smoothly step from JavaScript to TypeScript. And at some point you probably find that you've got this application, and maybe you find at some point that there are some hot bits of code that need to be optimized away. And we haven't quite fleshed out this story yet, but the hope is that you can then implement those parts in Rust and compile to WASM and be able to optimize things down to native code where necessary. But for the most part, I think most problems are engineering time bounded rather than CPU time bounded. And you just want to be able to move as fast as possible. Something different when comparing Node and Deno is Deno has a different set of APIs, and in particular tries very hard to be web compatible. So all of these web standard APIs are available in Deno. And we take this very seriously. In fact, Deno runs the web platform tests that browsers run to ensure that these are not just lookalike APIs, but are exactly what you expect, act exactly as they should in web browsers. And this is kind of an ever expanding list. You'll You of course have fetch out of the box. You have web streams, which is kind of part of the fetch API. You have web workers and message channel and local storage, WebSocket, abort controller. Thanks to Benji, a lot of more APIs are supporting that. We have web GPU support out of the box. It is an unstable API, but yeah, Deno you can program GPUs with Deno using web GPU. And as I said, it's unstable, but I have high hopes for this in the future. This allows you to do very interesting high performance things like advanced statistics stuff, machine learning models, and yeah, I think this web GPU support is going to become more visible over time. We've got blob, location, event target, text encoder, text decoder, on load, prompt confirm, alert, all sorts of stuff. You can have a look through. In fact, let me just open a terminal here. Here's my terminal, and if I type Deno and I type window, oh, by the way, we have the window object. You can just kind of scroll through this thing and have a look at all of the various APIs that Deno supports. Web crypto is coming along. So yeah, it's a very webby API. And this you know, in many ways, Deno can be considered a web browser. It's a headless web browser. It doesn't support all of the DOM APIs and stuff. It's explicitly for server side scripting, but it is a web browser in some sense, and as such is represented on MDN. So when you're browsing these browser compatibility tables, you'll see Deno represented all over the place. So yeah, the general idea is that you can just take code that runs on the web and run it on Deno relatively easy. That is the hope. Deno has this secure execution by default. So in Node, when we were developing Node, we plugged all sorts of holes in the system so that you could access the file system or you could access the network. V8 is a secure sandbox, and yeah, once you kind of plug a hole in it to open network connections, well, you know, you've kind of ruined the ability to ruined that feature of V8 that it acts as this sandbox. So by default, and let me just copy. Oh, I can't copy here. Sorry. Let me just copy this line here and come back over to my browser. So by the way, Deno can run URLs out of the box. So this is a URL to some TypeScript file or JavaScript file apparently that just does console log and welcome to Deno. Of course, when you go to this URL, you get this fancy HTML page, but we do some trickery. When you curl this, you actually just get the raw text here. And what's happening is that this web, when you go to the URL with the web browser, there's an accept header that says that it accepts HTML, and our website delivers this nice HTML page for you. But if you just do this with curl, you will just get the raw text, and as such, you can kind of pipe that right into Deno here. Deno knows how to download stuff and run it. So in this case, it has downloaded this welcome.ts. It has type checked it, of course, and then ran it. So where was I going with this? So I was talking about secure execution by default. So this program just prints out something to standard out. So it does not need access to the file system or to the network. And by default, it does not have that. So if you tried to fetch some website, it would error out. And so, of course, we want to enable people to access the network or access the disk. That is the purpose of a server-side scripting platform. But you kind of want to opt into these as necessary. And so we provide all these allow flags, like allow read to allow read access to the file system, or allow net to allow network access. And in this way, you can with some amount of confidence run arbitrary scripts and know that it's not going to be doing nefarious things. So in Deno, we use ES modules. There's of course no common JS require or anything. We want to live in kind of the modern JavaScript world. Just like you can run URLs directly from the command line like this, you can also import URLs directly from import statements. Amazingly, this actually works in web browsers as well. So this is really a simple and browser compatible module system. So this is our mechanism for linking to third-party code. And there's no notion of node modules or index.js or adding file extensions to module specifiers. It's not dependent on any centralized server. Of course, I linked to this Deno.land website, but you're free to not use that at all and use esm.sh or Cruxland or any other server that's hosting JavaScript, just like in the browser, right? The browser is not dependent on google.com existing. You are free to link to any CDN that you would like to. And we think that this can work for server-side code as well. I think something to mention is when I ran this the second time, you don't see this download message happening. In fact, this happens really fast. So Deno, like the web browser, has a cache, and it downloads this thing on first request because it doesn't have it in the cache. But when you go to run it again, we already have this downloaded. There is kind of a -- reload, which is kind of like Command R in the web browser, which will cause it to re-download. But generally, Deno is caching this stuff, and just for your information, if you look in this Deno dir, as we call it, you'll see all sorts of weird stuff in here, and I'll just leave it to you to have a look around at what the cache directory looks like. But it's an internal concept. So anyway, that's all to say, vendoring is possible, and you can work on an airplane with this. You do not always need network access. And I would argue that this is effectively the workflow of NPM and Node as well. I mean, you need access to npmjs.org to work properly, right? Like in order to install modules, and you need to be able to download and cache those things. So effectively we're just using this URLs, this browser standard to specify where to get the code from. It's these URLs are really nice concepts and happen to be part of the JavaScript standard. They specify a server and a path, and that happens to be exactly what you kind of want for a module system. We do support import maps if you're tired of writing these very long URLs. Yeah, Deno supports, has all this sort of built-in tooling. So if you type Deno help, you'll see all these subcommands. So there's like Deno bundle, Deno cache, Deno compile, Deno completions, Deno coverage, Deno doc, Deno eval, Deno format, Deno install, Deno lint, Deno LSP, Deno REPL, Deno run, Deno test, Deno types, Deno upgrade. I'm not going to go into everything that's here, but we essentially there's all of the JavaScript tooling that you want in there. Like we have all of this. We have a lot of compiler infrastructure and whatnot built into Deno, and we're exposing this to end users in the form of these tools. And so this should be all you need to get going. You don't need this large set of ancillary tooling to develop software. You can format your code with Deno format, and you can lint your code with Deno lint. By the way, like 100 times faster than ESLint, as is format and prettier. These are Rust implemented toolings. But yes, I'll allow you to dig through those yourself. I wanted to give just a small little demo of what it looks like to program in Deno. And to do this, I'm going to write a little program. And so what this program is going to do is it's going to get a URL from the first command line argument. It's going to fetch that URL. It's going to extract the server header. And then it's going to print the header, the value of that header to the console in a color, so that we can get a little usage out of the imports. Okay, so I've got the code right here, but I'm just going to go ahead and try to program this. So get server header .ts. And first of all, we want to get the first argument here. So let's do Deno args 0 is how we're going to get the first argument instead of process.argv, I believe it is in Node. And what I'm going to do is let's just start simple and try that. So we'll do Deno get server header, and then I'm going to say blah, and make sure that it prints that out. Okay, seems to work properly. Okay, so let's say this is going to be the URL then, right? And we're going to fetch that URL. And fetch is an asynchronous function, and so we'll await it, and we'll get the response, right? And by the way, top level await, yes, we have that. Console log response. Let's log that out and make sure we're getting something. So now I have to give it a URL. Let's do google.com. Okay, and now I'm getting an error. It's saying uncaught permission denied requires net access. This is what I was mentioning before, that without any arguments, this is somewhat of a secure sandbox here. And so what it can do is do this allow net, and that will give it network access, and that allows us to see the response here. We could narrow this network access just to google.com, for example, and it's not liking that because I think that there's a redirect happening into www.google.com. So kind of the fetch forwarding is not allowing that to happen. Another thing we could do is prompt, which will kind of allow us to kind of interactively walk through all of these network accesses. So Deno requests net access to google.com. Allow. Let's say yes. And then it says Deno requires net access to W because we got redirected. Yes. Okay. And then finally we get the response here. Okay. So far so good. Now we want to extract the headers, right? So res headers. My fetch knowledge is not extremely great here, but let's try server and let's see if this works. Console log server. Okay. So maybe just do this allow net. Okay, that seemed to work. So I've extracted the server. Oh, and by the way, you know, I'm editing here in Vim because I am very old. But Deno does have a LSP built in, language server protocol that can interact with fancy IDEs like VS Code. And because we're using TypeScript and stuff, you get very nice tab completion for those of you used to not programming like we are in the 70s. But this is just how I do it. So apologies for that. Yeah. Oh, and we wanted to print this in magenta, and there is this magenta function in denoland/standard/fmt/colors.ts. So let me just import that. Import magenta from HTTPS denoland std fmt colors.ts. And what we'll try to do here is wrap this header value in that. Let's see if that works. Should download that guy. Okay, and we are getting a TypeScript error here, which is saying the argument of type string or null is not assignable to parameter of type string. Well, that's because this is potentially a null value here, and if I add a little exclamation point, I believe that should make TypeScript happy. And yes, we are able to print the header there. And notice I'm not downloading the colors script anymore when I run it a second time. By the way, I should mention the Deno standard library. So Node basically has the standard library built into the executable. We've decoupled this in Deno because we've got this fancy URL fetching mechanism. And in here, we've got all sorts of nice utilities that you might need. For example, formatting colors, and we do have some nice documentation browsing tools here, so you can have a look at all the fancy terminal utilities you might want are available, and yeah, lots of other stuff. UUID, WASI. I think one thing to mention is Node support. There is this std/node, which kind of implements some of the Node APIs. It is not complete, but is kind of growing in parity with Node. So this std/node allows you to port Node code over to Deno in an easier way. But I digress. I'm getting off topic. So yeah, that's just a little flavor of Deno. Yeah, Deno is an amalgamation of many different technologies here, and it's worthwhile just to let you know how we make this possible. This is, of course, built on top of V8, the best JavaScript VM in the world. Rust is used very heavily, and we are quite a large Rust project with many different crates. We use the Typescript compiler from Microsoft, which is written in JavaScript. We use Tokio. This is essentially the equivalent of our library libuv that we previously wrote for Node. We felt no need to rewrite this. This exists already in Rust. It's called Tokio. SWC, I already mentioned, is a JavaScript TypeScript parser. It's used in lint and docs and dependency analysis. We use a library called rusttls instead of OpenSSL. We use Hyper and Request, which are HTTP libraries in Rust. We use WGPU for the WebGPU implementation, Tungstenite for WebSockets, et cetera, et cetera. I think my point here is that one of the main advantages of Rust, as I see it, is the fact that there is this crate system and there is a defined build system. When we built Node, C++ is very difficult. It's very difficult to link in third-party libraries. It's so difficult that I ended up writing an HTTP server from scratch to implement Node's HTTP libraries. It's not very possible to simply link in third-party C++ code. It requires a lot of difficulty, I think the main benefit of Rust, as I see it from a maintainer's perspective, of course, Rust has many great features, but the ability to kind of pull in and utilize all of this third-party code allows Deno to make great strides very quickly. Something that Benji noted before. We mull over decisions very carefully, and sometimes things get stuck. But once we kind of decide on a direction for things, they tend to move. We tend to be able to move very quickly because of this. It's worth mentioning that Deno is not a monolithic program. The system is broken up into several crates, which allow people to roll their own JavaScript VM. So this is, it's worth mentioning Rusty V8, which is our safe Rust wrapper around V8. Very non-trivial. Took us years to figure out how to do this. It both interfaces, it's both a wrapper around the C++ APIs at zero cost wrappers, but also importantly, an interface to V8's build system, which is GN, and interfacing with that properly is non-trivial. I will just say that. Deno Core is a wrapper around Rusty V8, and this is starting to make Rusty V8 is essentially exactly the C++ V8 API, but in Rust. Deno Core starts making this much more nicer to use. So it provides this op system that essentially connects JavaScript promises to Rust futures. So we really have kind of asynchronity in both worlds. Asynchronity is the word. Serity V8 is a very slick piece of technology that essentially allows us to bind gen calls from JavaScript into Rust in a fairly optimal way. I won't go into that in any detail. Deno /extensions, I think has been recently renamed to Deno ext. I'll just point this out here. Is a directory of subcrates where we implement various APIs. So if you want, you can pick and choose which API. Maybe you want to build a JavaScript runtime that does not have the HTTP server in it, or does not have WebSocket in it, or does not have a web GPU. You find this ridiculous. Well, you can mix and match as you desire here, and we've neatly broken this up into various pieces for that specific use case. By the way, speaking of Deno's HTTP server, it's based on Hyper. It is a native Rust web server, and it is fast. This here is response time histograms showing at the top Deno 1.9 versus Node in the middle versus Deno 1.9 with our previous HTTP server. Farther left is better. That is lower response times. So yeah, we have kind of a web server built in, and it is we have just started optimizing this. This has been a long time coming, and there is more to come. Look out for blog posts on this in the future. We hope to really push this to the limit and make sure that you can serve HTTP as fast as possible. By the way, this supports HTTP 2 out of the box, I think it's looking quite nice. I should mention the Deno company. This is a for-profit endeavor. I think it makes sense when developing technology to have stakeholders who are invested in the project. Of course, we all believe in open source, and Deno remains MIT licensed and will forever remain that way. Big complex projects like Node or Deno need a revenue stream. Engineering, it might seem like Node, for example, is just an amalgamation of random engineers coming together to create this thing, but that is not how Node was made. Node was made with funding and very specific high quality engineering work. And we need the same in Deno, and high quality engineering work is not free, I assure you. So yeah, we're trying to build a company here. Of course, we're Deno, this open source project is what we're building, but we hope to build a business around this as well. I mentioned earlier that you can kind of roll your own JavaScript VM. We've done this kind of explicitly in mind with our new product, Deno Deploy, which is a new VM. It is I've written 3 JavaScript VMs in my life. The first one was Node, the second is Deno, and the third is Deno Deploy. So this is a VM specifically designed for kind of a serverless model, and it is a globally distributed JavaScript VM. And in some sense, it's very similar to Cloudflare Workers. We provision you a subdomain, and we can execute JavaScript when people access that subdomain. So you can essentially, it's a programmatic web server. We use Anycast. We have an Anycast IP address, and that routes requests to the nearest data center, which we have 22 of at last count. Which means that you're always accessing something very close to you. In some ways, you can think of this as a dynamic CDN. So you're executing JavaScript at the edge, as they say these days. We like this model because we can optimize it end to end. This is not built on Cloudflare Workers. This is not built on AWS Lambda. This is from scratch, end to end, our work, and we hope to optimize this end to end and build very nice APIs that allow people to move very quickly in developing cloud infrastructure. So things like broadcast channel allow you to send events to broadcast events between all of these different VMs running worldwide. We're thinking about persistence. It's not there yet, and there's more APIs to come. We're very excited and having a lot of fun developing this. This is a closed source proprietary system, and yeah, it's a hosted Deno. So this is what we hope to build a business around. So it is in beta. And it's provided for free right now. So please check it out. Give us some bug reports. But of course, if you don't like Deno deploy and this is much too nascent for you, by all means take Deno and take the MIT licensed binary that we distribute and build your own web service. That is by all means acceptable and encouraged. So yeah, that's the end of my talk. I hope I haven't gone over time. I apologize if so, but thank you for your attention, and feel free to email me if you have any offline questions.
Awesome. Thank you very much, Ryan. It's always really interesting to see the project progressing, and obviously, congratulations on the company. It's a huge step, and you get to do it as a part of the deciding team now, and as a founder. That's probably super exciting. The idea of running Deno off more lightweight containers isolation layer is very interesting. I remember a project for Microsoft that ran like C# without system calls called Singularity once. It's like an extension of C# that was very interesting. I think they ended up using it in Azure for something, but it's a really interesting concept. Right, so we have some questions. So thank you for the talk, first of all. Raz asked how you can track outdated dependency versions.
Well, you can. So yeah, we don't have these fancy utilities that NPM has, where it can NPM audit and whatnot. It is a simple module graph, and so the question is, what does it mean to be outdated? We have no mechanism for that. So you have to roll your own solution there. Yeah, I would say if it becomes a big enough problem, we would develop a tooling around it. But generally, I would kick this into user space as a problem.
Cool. Next question. I think I asked one. Alon, can you move to the next? Okay, cool. So you mentioned like a bunch of these amazing tools like Deno Lane, Deno Format, Deno Bundle. Can I use it? And by can I mean like, is it a supported use case on non-Deno apps? Let's say I'm like writing front-end code using React, for example.
Yes, but your mileage may vary, and the hope is that you would be able to do that. I think in particular, Deno Bundle has had a lot of controversy about whether or not how we support web browsers there, but that is a goal. I'm not sure how it's a complicated answer about how well we're delivering on that goal right now.
Yeah, but it's a very cool idea. Like as you said, these tools are very slow right now, and developers need something fast to do their linking. Cool. Next question. Omri asked, can Deno show function signatures from TypeScript to built-in functions in the REPL?
No. So the REPL does have TypeScript support, but it basically does the type stripping automatically. So we do not try to we do not try to do type checking in the REPL, and as such, the REPL is fairly dumb and doesn't know what's happening when it comes to signatures and whatnot.
Cool. Alon, next one. Cool. Julie asked, what in your opinion is still missing in Deno?
Well, I think there's a lot of existing JavaScript code out there, and there's a lot of people who are using Node, and it's a large lift to get people. I think a lot of people would like to use Deno, but just find it inconceivable that how they would do that with kind of an existing code base and existing tooling all built for Node, and so. I think kind of the main missing piece is, and by the way, I don't expect large code bases to be ported to Deno. Like this is just too much of a large undertaking. But I do hope that new code bases would be thinking about Deno as something they could use. Anyway, that's all to say. I think our Node compatibility could be better. I mentioned this std/node. Kind of compatibility layer. And yeah, I want to make the story there better and easier for people to not have this massive fragmentation in the JavaScript world. But that said, I mean, Node, we're trying to change some things, and it is fundamentally incompatible. And there are very good reasons for making these changes. So yeah, it's kind of a mixed bag.
Mm-hmm. Yeah, good answer. I think it's always very tricky. You want to only support like the new. Yeah, that's the thank you. You want to only support like the new correct version to not have to maintain a lot of legacy like Node. But if you end up supporting like Node apps, you end up taking all that legacy. So it's well, not all of it. Like you don't take like the build system and a lot of the weird stuff, but it's tricky. It's a challenge. Lots of decisions. I have another like last question before Alon kills me because we're over time. A lot of the web APIs I noticed are kind of wonky, like to code in that they are writing like in several places when working on web APIs in Node. You run into things like that were simply written from a browser perspective. Like when you implement fetch, there is no concept of like all the concept and security and headers. Everything is very browser centric. Like, are there any regrets about those APIs, or is it like worth the sacrifice in a sense?
I guess I'm not sure what you're saying. I mean, how is it wonky? And
I'll give an example. Let's say event target is a very fundamental and like important API in the web world. It's a very wonky API. It has a lot of weird behavior.
Yeah.
There is kind of like a very fine balance where you're saying, I have all this wisdom from like years of coding and like writing async JavaScript platforms, and I'm gonna take all that like learned knowledge and I'm gonna still implement like that API because it's standard.
Right. Yeah, it's often very painful to do this stuff. One example is with the streaming APIs. I hate the web stream APIs. I think they are just absolutely wrong and very, very bad. And I have, Deno, one of the first APIs that I implemented was essentially a port of Go's reader and writer, which is essentially their stream API. It's very simple, very elegant to Deno, to JavaScript, with the idea that this would be the streams of the future. Yeah, very sadly, it's we see browser compatibility as more important than kind of getting the APIs right, and it's a hard pill to swallow. Often, a lot of these APIs are not exactly what you want, but this is what people know. This is what people expect there to be, and so yeah, it's difficult, but I think the nice thing is that these web platform tests kind of take the burden off of us from designing these APIs. And it's just like, this is the way browsers work. And we are a browser, so we must conform to that.
Cool. Yeah, it's tough, but it's always like nice to talk and see how far you're gone. Like you've progressed since the last time. It's really nice stuff, amazing progress. And good job, and thank you for the talk. Cheers.
Thanks for having me.
Bye.